limit of root pi minus root of cos inverse x divided by root x plus 1 as extends to minus 1. Again here x equal to minus 1 means what? Minus 1 plus 1 is 0. So clearly you are getting 0 divided by 0 form and is the L-Hospital rule. By using the L-Hospital rule, limit of now derivative of root pi is 0 because it is a constant number. Next minus. Now derivative of root of cos inverse x means it is of the type root x. What is derivative of root x? 1 upon 2 root x means 1 upon 2 root cos inverse of x into derivative of this cos inverse x. What is derivative of cos inverse root x? 1 upon root of 1 minus x square. Suppose if you have not studied this derivative of cos inverse and inverse, in the second year you are going to study. So remember, derivative of cos inverse x equal to minus 1 divided by root of 1 minus x square divided by. Now here once again it is of the type root x. What is derivative of root x? 1 upon 2 root x plus 1 into derivative of x plus 1 is 1 as extends to what? Extends to minus 1. That is equal to here minus into minus is plus 1 divided by 2 into root of cos inverse of x. Next into, now this root of 1 minus x square you can write it as root of 1 plus x into 1 minus x. I hope you understood the step now. Root of 1 minus x square means 1 plus x into 1 minus x and divided by 1 divided by 2 into root of x plus 1. Now this 1 upon 2 root x plus 1, 1 upon 2 root x plus 1 get cancelled. That is equal to limit of, now the finally left terms are 1 upon root of cos inverse of x and into root of 1 minus x as extends to minus 1. That's equal to 1 divided by root of cos inverse of, what is x value? Minus 1 into root of 1 minus of minus 1. That's equal to, now cos inverse of minus 1 is pi. So that is 1 upon root pi. Similarly, this one is 1 plus 1, that is 2, equal to 1 upon root of 2 pi is the answer. So that is the first option is the answer. Okay. Now limit, next example, if alpha is a repeated root of ax square plus bx and plus c equal to 0. Okay. Then limit of tan of ax square plus bx and plus c and divided by x minus alpha whole raised to square as extends to alpha. The options are, the first option is A, second option is B, and third option is C, and the last option is 0. First option is A, second option B, third option C, and the last option is D. Students, one point I would like to bring for your notice that whenever roots are given, your first job is to calculate sum of the root as well as the product of the root. A root is given here. Alpha is a repeated root, means the two roots are alpha and alpha. So they are not different. Roots are equal. Alpha and alpha are the two roots. So therefore, what is sum of roots here? Sum of roots is equal to minus b divided by a. What is b? B itself divided by a. It is equal to alpha plus alpha. Sum of the alpha plus alpha is equal to 2 alpha. Just here, minus b upon a equal to 2 alpha. So by means of this, you can reduce an equation 2a alpha plus b equal to 0. Similarly, you can use a alpha square plus b alpha plus c equal to 0. I'll repeat these 2 points once again. Alpha is a repeated root, means the two roots are alpha and alpha. So therefore, sum of the root is what here? Alpha plus alpha is given by minus b upon a. That is 2 alpha equal to minus b upon a, or 2a alpha plus b equal to 0. Means Whenever there is an expression 2a alpha plus b is 0, you can replace it by 0. Similarly, alpha is the root of this equation. So therefore, that alpha must satisfy this equation. A alpha square plus b alpha plus c equal to 0. Now, to find the limit of this one, let me make use of the L-Hospital rule. That is limit of. Now, what is the derivative of tan? Derivative of tan is secant square ax square plus bx plus c, and into derivative of ax square plus bx plus c. What is derivative of ax square? 2ax plus b, and derivative of c is 0, and divided by derivative of x minus alpha whole raised to square is given by 2 into x minus alpha as x tends to alpha. See, almost all the derivatives you are getting under the composite function. Means derivative, most of the derivatives under the composite function. Now derivative of tan ax square plus bx plus c is what? Derivative of tan is secant square ax square plus bx plus c into derivative of ax square plus bx plus c means what? 2ax plus b. Now after this, after using the L-Hospital rule, see, you are going to replace x by alpha. So alpha minus alpha means what? 0. So that is numerator is 0 form. And what about if you put x equal to alpha? 2a alpha plus b equal to 0. What is 2a alpha plus b equal to 0? Again it is 0. Means again you are getting the 0 upon 0 form. Once again, let us make use of L-Hospital rule. That is limit of, even after using the L-Hospital rule, again you are getting 0 upon 0 form. So once again, this method is further continued. Now, there means use the product rule here. What is the derivative of secant square 2ax square plus b? That is 2 times sec of ax square plus bx plus c, and into derivative of sec means sec of ax square plus bx plus c, and into tan of ax square plus bx plus c, and into this term, that is 2ax and plus b. Next plus. Now this term is kept constant. Sec square ax square plus bx plus c into what is the derivative of 2ax plus b? Derivative 2a is constant, derivative of x is 1 and derivative of b is 0, divided by denominator 2 is constant, derivative of x is 1 and derivative of alpha is 0 as x tends to alpha. See, once again I will explain this point. Derivative of secant square 2 times sec of ax square plus bx plus c into derivative of sec means sec of ax square plus bx plus c into tan ax square plus bx plus c. The second term is kept constant. Now keep the first term constant into derivative of the second term as x tends to alpha. Now wherever a alpha square plus b alpha plus c is there, it comes to 0, and 2a alpha plus b also equal to 0. Means this whole expression is multiplied by 0. So that means it is 0. Then plus this expression secant square 0 and into 2a divided by 2 and into 1, because this is 0, secant square 0 plus 2a. Now this 2 and 2 get cancelled. Sec 0 is how much? 1, and into a equal to a is the answer. So which option? That is first option is the answer. Limit of 1 divided by 1 plus n into sine square nx, sine square nx, as n tends to what? N tends to infinity. Now the first option is minus 1, and the second option is plus 1, and third option is 9, and the last one is none of these. For the example here, limit of 1 divided by 1 plus n into sine square nx as n tends to infinity. Suppose here there are two options are there. First option is what? If this expression is 0, and second one if it is non-zero. If x is not equal to n pi, means x is not a multiple of pi. Pi it is, what is the sine pi? Sine pi is 0. So if x is not equal to n pi means what? you are getting sine square n into x is not equal to 0. So that means it is some value. So therefore, limit of 1 divided by 1 plus n into sine square n into x as n tends to what? N tends to infinity. That's equal to 1 divided by 1 plus n. What is n value? Infinity. And here this expression is not equal to 0. Not equal to 0 means what? Sine square is there. Means always it is a positive. So it is some finite number less than 1. Some finite number less than 1. So finally what we are getting here? 1 upon infinity. What is 1 upon infinity? That 0 is the value. So that means when you are taking x is not equal to n phi, the limit you are getting 1 upon infinity, that is 0. Suppose if x is equal to n pi, sine square n into x value is how much? It is 0. So therefore, limit of 1 divided by 1 plus n into sine square nx as n tends to infinity is equal to 1 divided by 1 plus infinity into 0. That is 1 divided by 1 is equal to 1. So that means one of the limit. You can say that left hand limit and the right hand limit. So both of these two limits are not equal. So that means limit does not exist. What you can see here? Limit does not exist. So when limit does not exist, which option you are going to mark here? There is none of these is the answer. See, if it is not multiple of n pi, sine square nx is not 0. When sine square nx is not 0, you are getting infinity to some finite number. What is infinity to some finite number? Infinity. So 1 upon infinity 0. Similarly, if it is n pi, sine square x equal to 0, you are getting 1 plus infinity to 0. That is 1 by 1 is equal to 1. So both of these two limits are not equal. So therefore, the option is none of these. Limit of root of 1 plus x raised to 4 minus into the bracket 1 plus x square divided by x square as x tends to infinity. The first option is minus 1 and the second option is 0 and the third option is 2 and the last one is none of these. Okay, students, remember here, whenever x tends to infinity is there, try to cancel the highest power existing in both numerator as well as denominator. X tends to infinity or n tends to infinity, try to cancel the highest power which is available. After cancelling, suppose if you are getting 1 upon infinity equal to 0, and if it is infinity you are getting, infinity is not defined. So first let us see, try to cancel the highest power of x. In the denominator, highest power of x is 2, and in the numerator, here the highest power of x is 2, and here root of x raised to 4 means highest power root of x raised to means x raised to 2. So now let me take x square as a common factor in both numerator and denominator. X square into the bracket, root of, you are taking outside. So 1 divided by x raised to 4 plus 1. Next minus into the bracket, 1 divided by x square plus 1. Complete this bracket and divided by denominator is x square as x tends to what? X tends to infinity. Is it clear? Root of x raised to 4 means x square you have taken. So root of 1 upon x raised to 4 plus 1 minus into the bracket 1 upon x square plus 1 divided by x square. Now these x square and x square get cancelled. Now whenever x is there, put x equal to infinity. So that is root of 1 upon infinity plus 1 minus 1 upon infinity plus 1 and divided by 1. Now that is 0 plus 1 and minus of 0 plus 1 divided by 1. What is the numerator value? 0 divided by 1 equal to 0. Which option? And the second option is the answer. So remember, whenever the limit tends to infinity is there, try to cancel the highest power of numerator as well as the denominator. After cancelling, if you are getting 1 upon infinity, the answer will be 0. If it is infinity, then infinity only. Limit of 1 plus 3x divided by 2 plus 3x raised to 1 minus root x divided by 1 minus x as x tends to infinity. The first option is 0, the second option is minus 1, and the third option is e, and the last one is 1. Students, here this example is coming under type f of x raised to g of x as x tends to infinity. What is f of x raised to g of x? Limit of e raised to g of x into the bracket f of x minus 1. Now first, before going to that, now let me simplify this one. That is limit of 1 plus 3x divided by 2 plus 3x raised to 1 minus root x divided by 1 minus root x into 1 plus root x. Is it clear this step, students? 1 minus root x into 1 plus root x into 1 minus root x square. What is 1 minus root x square? 1 minus x. So that means this 1 minus root x and 1 minus root x get cancelled. So I am right here GL, that is given limit, is equal to limit of 1 plus 3x divided by 2 plus 3x raised to 1 upon root of 1 plus 1 upon 1 plus root x as x tends to what? X tends to infinity. Now clearly it is of the type f of x raised to g of x. What is f of x raised to g of x? That is e raised to limit of g of x, that is 1 upon 1 plus root x into the bracket f of x means 1 plus 3x divided by 2 plus 3x minus 1 as x tends to infinity. That's equal to e raised to limit of 1 divided by 1 plus root x into the bracket 1 plus 3x. Now take LCM here. Minus 1 into 2 means what? Minus 2 minus 3x divided by 2 plus 3x as x tends to what? X tends to infinity. Now this 3x and 3x get cancelled. That is equal to e raised to limit of 1 upon 1 plus root x into the bracket 1 and minus 2. 1 minus 2 means what? Minus 1 divided by 2 plus 3x as x tends to what? X tends to infinity. Now put x equal to infinity now. That is e raised to 1 divided by 1 plus infinity minus 1 divided by infinity. That means e raised to minus infinity. You are getting e raised to minus infinity. What is e raised to minus infinity? 1 upon e raised to infinity. That is 1 upon, that is 0, e raised to 0. And what is e raised to 0 value? Is equal to 1. 1 upon infinity. E raised to minus infinity. So that means here e raised to minus 1 divided by infinity. That is equal to e raised to minus 0. 1 upon infinity 0. What is e raised to 0? E raised to 0 equal to 1 is the answer. Here. 1 upon 1 plus infinity minus 1 divided by 2 plus infinity means totally you are getting minus 1 upon infinity. What is 1 upon infinity? That is 0. So e raised to minus 0 is nothing but 1 is the answer. Which option? That is the last one. D is the correct. Now limit of 1 plus tan x divided by 1 plus sin x raised to 1 upon sin x as x tends to 0. Okay, here the options I am going to write here. The first option is 0, second option is 1, and the third option is minus 1, and the last one is none of these. Okay, so is the example once again of the type f of x raised to g of x. F of x raised to g of x equal to e raised to limit g of x. What is g of x here? 1 upon sin x into the bracket f of x 1 plus tan x and divided by 1 plus sin x and minus 1 as x tends to what? X tends to 0. First step, e raised to g of x into the bracket f of x and minus 1. That is equal to, now let us try to simplify now. E raised to limit of 1 divided by sine x into the bracket. Now if you take LCM, what is LCM here? 1 plus sine x is LCM. So numerator now 1 plus tan x and minus 1 and minus sine x. Okay. Now here plus 1 and minus 1 get cancelled as x tends to what? X tends to 0. That's equal to e raised to limit of 1 divided by sine x into the bracket. After this, see here. Tan x is there, that is sine x upon cos x and minus sine x is there. So I'll write here sine x upon cos x minus sine x and divided by what? Divided by 1 plus sine x as x tends to what? X tends to 0. That is equal to e raised to limit of 1 divided by sine x as it is. Now can you take the sine x as a common factor here in the numerator? If you take sine x as a common factor, then you are left with 1 minus cos x. Then this cos x is coming to denominator, cos x into the bracket, 1 plus sine x as x tends to 0. Now let me explain this step once again. 1 upon sine x, you have taken sine x as a common factor, 1 minus cos x divided by cos x into 1 plus sine x. Now this sine x and sine x get cancelled. That's equal to, whenever x is there, put x equal to 0 now. That is e raised to 1 minus cos 0 divided by cos 0 into the bracket 1 plus sine 0. That's equal to 1 minus 1 e raised to 1 minus 1 divided by 1. Is it equal to e raised to 0? E raised to 0 value is equal to 1. So again, which option is there? That is the first one. So these type of examples, the new for you, f of x raised to g of x. So f of x raised to g of x equal to, remember this formula, e raised to limit g of x into the bracket f of x minus 1. Now limit of cos x plus a into sine bx raised to a upon x as x tends to 0. Limit of cos x plus a into sine bx raised to a upon x. The options are, the first option is e raised to minus a square upon b. Second option, e raised to ab square. And third option, e raised to a square b. And the last one is e raised to minus b square divided by a. See the all options now. Again, use the same formula. That is e raised to limit of g of x. What is our g of x value? A upon x into the bracket f of x, that is cos x plus a into sine bx and minus 1 as x tends to what? X tends to 0. See here? After this, earlier what used to happen? Some of the term used to get cancelled, then you used to find some common factors in the numerator and denominator. Here such thing is not there. Now let me put x equal to 0, 1 and minus 1 get cancelled. Then this becomes what? Sine 0 is 0 and here upon 0. So you are getting 0 upon 0 form. That is e raised to 0 upon 0 form. So now let me make use of the Y.V.Patil rule. E raised to limit of a into the bracket. Derivative of cos x is how much? Minus sine x plus a is constant. Derivative of sine bx is cos bx into derivative of bx is b. A constant, derivative of sine bx is cos bx into derivative of bx is b, minus derivative of 1 is 0 and divided by derivative of x is 1 as x tends to what? X tends to 0. That's equal to e raised to, now a into the bracket. When you put x equal to 0, what is sine 0? It is 0 plus a is constant. Now cos bx, that is cos 0 is 1 and into b, or that is equal to e raised to, so this expression a into ab, what is a into ab? E raised to a square b is the answer. Is there any option e raised to a square b? Then the third option is the answer. So one more example I would like to take of this type, then we will change the examples. Limit of x square minus 2x plus 2 and divided by x square minus 4x plus 1 and raised to x as x tends to infinity. X square minus 2x plus 2 divided by x raised to 4 minus 4x plus 1 raised to x as x tends to infinity. The first option is e raised e square, and the second option, this is e raised to minus 2, second option is e square, and the third option is e raised to minus 1, and the last option is 1. Okay, see here, e raised to limit of g of x, that is x into the bracket, f of x means x square minus 2x plus 1 and divided by x square minus 4x plus 1 and minus 1 as x tends to infinity. Okay, so that is equal to, the very purpose of using this formula is what? In order to cancel the highest powers of both numerator and denominator. That is e raised to limit x into the bracket. Now let me take the LCM. What is LCM here? X square minus 4x plus 1. Now this is x square minus 2x plus 1. Now minus 1 into this term. That is minus x square plus 4x minus 1. Understood? Minus 1 into x square is minus x square. Minus 1 into minus 4x is plus 4x. And minus 1 as x tends to what? X tends to infinity. Here x square and x square get cancelled. Even plus 1 and minus 1 get cancelled. That is e raised to limit of x into the bracket. Minus 2x plus 4x is how much? 2x. And divided by x square minus 4x plus 1 as x tends to what? X tends to infinity. So after this, just see the highest powers of x in the numerator and denominator. X and x square, and here also x square. So that means e raised to limit of here 2 times of x square divided by, I am taking x square common factor into the bracket, 1 minus 4 upon x plus 1 upon x square as x tends to infinity. Now this x square and x square term get cancelled. That's equal to e raised to 2 divided by this value is 1 minus 0 and plus 0 equal to what? E square is the answer. So that is E square. So here we took the examples of the type f of x raised to g of x. What is the method to solve such type of examples? Use the formula limit of f of x raised to g of x is equal to e raised to g of x into the bracket f of x and minus 1. Now the students, next example, limit of modulus of x minus a divided by x minus a as x tends to what? X tends to a. The first option is 1, second option is minus 1, and the third option does not exist, and the last one is 0. Students, in the previous section I had told you, whenever the greatest integer function comes, whenever the modulus function comes, and whenever the sign of function comes, limit does not exist. Limit does not exist. Straight away you can write limit does not exist. Even then, I'll just explain how the limit does not exist. Let us see now. Now, LH, that is left hand limit, equal to limit of modulus of x minus a divided by x minus a as x tends to a minus. Student, what do you mean by x tends to a minus? X value is less than a. When x is less than a implies x minus a is less than 0. Are you understanding this term? When x is less than a, bring this term x minus a is less than 0. When x minus a is less than 0, what is modulus of x value? Modulus of x will be minus x. So that is equal to limit of, now this term becomes what? Minus of x minus a divided by x minus a as x tends to a. Now this x minus a and x minus a get cancelled. There is minus 1 is the left hand limit. Now right hand limit equal to limit of modulus of x minus a divided by x minus a as x tends to a plus. Now x tends to a plus means what? X is greater than a. When x is greater than a, x minus a is naturally greater than 0. Now similarly here, when x minus a greater than 0, this modulus of x will be equal to plus x. Means modulus function is what? This term will be negative if this expression is less than 0. It will be positive if it is greater than 0. Now here x minus a is greater than 0. So therefore the numerator expression is positive. That is limit of, it is x minus a divided by x minus a as x tends to a. Now means after substituting, just cancel this one, write x tends to a. That is x minus a get cancelled. That is 1. What is left hand limit here? Minus 1. What is right hand limit? Plus 1. So LHL is not equal to RHL. So therefore limit does not exist. So whenever the modulus function, greatest integer function and the sign of function comes, you can write limit does not exist. Now slowly we are moving toward the difficult level questions, students. Limit of, here cos x raised to 1 by 2 minus sin x raised to 1 by 3 and divided by sin square x as x tends to 0. The first option is 1 by 6 and the second option is minus 1 by 12 and the third option is 2 by 3 and the last option is 1 by 3. Cos x raised to 1 by 2 minus sin x raised to 2 by 3 divided by sin square x. X equal to 0 means cos 0 is 1, root of 1 is 1, sin 0 is 0. So 1 minus 0 is here and denominator sin square x is there as x tends to 0. So that means when we put x equal to 0 here, so it is not sin x square, just sorry, it is cos x. Cos x. So 1 minus 1 is 0 and divided by 0, that means 0 upon 0 form. So use the Y.V.Patil rule here, LHR, that is limit of. Now what is the derivative of cos x raised to 1 by 2? It is 1 by 2 into cos x raised to 1 by 2 minus 1. N minus 1 is minus 1 by 2 into derivative of cos x. What is the derivative of cos x? Minus sin x. Let me explain it once again now. Power you are differentiating first, 1 by 2. Cos x raised to 1 by 2 minus 1 is minus 1 by 2 into derivative of cos x is minus sin x. Next minus 1 by 3 here. Cos x raised to 1 by 3 minus 1. What is 1 by 3 minus 1? Minus 2 by 3. And once again derivative of cos x is minus sin x. And divided by here sin square x derivative 2 sin x and into cos x as x tends to what? X tends to 0. See, sin x is common factor in the numerator and even the denominator is there. So let me use the common factor formula now. Here sin x you are taking common factor into the bracket, 1 by 2 into cos x raised to minus 1 by 2 and minus here 1 by 3 cos x raised to minus 2 by 3 and divided by here minus and into minus you can write plus and this expression is minus divided by 2 times of sin x and into cos x. Okay. Then after this sin x and sin x term get cancelled. So what is the expression left afterward? Just see here, as x tends to 0 you are writing here. Sin x and sin x get cancelled. The numerator is now minus 1 by 2 into 1, because when x tends to 0, cos x is 1, and plus 1 by 3 and into 1 divided by 2, that's equal to 1 by 3 minus 1 by 2 divided by 2 is there. If you take LCM here, 2 minus 3 divided by 6 divided by 2 equal to how much? Minus 1 divided by 12 is the answer. That is the second option is the answer.